30-1. So we are going to talk about tangent functions today. So this is a pretty short little one. You really just have to know what a tangent function looks like and why does it have very specific properties. What is the period of a tangent function? And that's pretty much it. You really don't have to do too much other than that. So it's pretty easy to do. It's really, you can see here it's only 2 pages long. And then we'll get into some more complex equations in the next lesson. So when we're doing this, let's start plotting these points here. So let's look at the unit circle. Okay, let's look at the unit circle here that we have. We're just going to draw the unit circle up here. This is for the graph later on. So I'm going to draw my unit circle here. You can pull out your unit circle that you have. I'm going to try to recall it as much as possible. I'm going to plot some points that we have, and then we're going to look at some corresponding points over here in the negative and positive quadrants, or angles that we have. So let's say we have this point here, which is 1, 0. Okay, just 1 second. If I go straight up here, I don't really need to know that, but let's say I did go straight up. If I went straight up, I would have 0, 1, and then if I went straight down, I have 0, negative 1. If I went straight backwards, I have negative 1, 0. So those are the quadrantal coordinate points. Then I'm going to go around here. So like here we have a few different angles, like pi over 3. If this pi over 3, if I remember correctly, is 60 degrees. Pi over 4 is 45, and pi over 6 is 30 degrees. So at the 30 degrees, about there, this point, let's just do that one here. So I'm going to do the 30 degrees. Actually, let's just do the 0 one first. 0 degrees, the point is 1, 0. Okay, that's going to be important for later. 30 degrees, remember our points here represent, this is the x, this is the y. So if this is 30 degrees, or pi over 6, the shorter side is the y, so that's the half side. The long side is the root 3 over 2. At 45 degrees, I'm going to run out of space here. Should make these a little bit bigger. 45 degrees, this is going to be the 1 over root 2, or root 2 over 2, up to you. All right, so it's up to you. How do you write that? I could write root 2 over 2, 2 over 2. Okay. And then at 60 degrees, now the longer side is the y value, so they're going to switch here. So this is going to become 1/2 root 3 over 2. Okay. And if I go down to the bottom quadrant, you can see that the y values will just be negative there. X values stay positive. Okay, so 30 degrees, our corresponding point here, which we just wrote at the picture that I drew up there, is root 3 over 2 1/2. This is going to be 1 over root 2, 1 over root 2, and this is going to be 1/2 root 3 over 2. Now I'm going to go backwards in the negative quadrant, so this is just going down here now. All my y values are going to be negative, but my x values stay the same. So this is going to be negative 1/2 here. This is going to be negative 1 over root 2 here, and this is going to be 1/2. Cool. Looking pretty good. Now what we're going to do is we're going to determine the tan of all of these angles. Okay, so remember what tan represents. And tan represents a few different things. It represents, down here, it could represent sine over cos, or it represents y over x. And that's probably more important for this one. Remember, sine is y on a unit circle and cos is x on a unit circle. Anyway, so I'm going to go y over x. So I'm going to do the math for all of these y over x for all of this. I'm going to go negative root 3 over 2, and then divided by the x value of 1/2. That's going to be the same as this one down here. Divided by 1/2. You take the reciprocal, you're going to multiply it. And by doing that, the 2's cancel out. I'm left with negative root 3. Negative root 3. Okay. Next one here. I'm taking a number and dividing it by itself, but the top one's negative here. So I get negative 1, and the same thing's going to happen with this one down here. So I get positive 1, though, for this one. Here I'm going to go negative a half divided by root 3 over 2. Now, when I do this one, the 2's are going to get cancel out. I'm going to get negative 1 over root 3. Or if I do it for this one, I get positive 1 over root 3. And then this last one here, I'm going to have y, which is 0 over 1, which ends up being 0. Okay. Later on, we'll talk about what happens at the 90 degrees points. And we'll see what happens there when you plot this. So what I'm going to do now is I'm going to plot some of these points. So I'm going to plot the first point, 0, the angle 0, and the tan is 0. So my angle 0, tan is 0. So I'm going to put that point there. The next point here, I'm going to go on both sides. You can do it on both sides because they're both going to be essentially the same. I'm going to go pi over 6 or negative pi over 6. And then I either get negative 1 over root 3 or 1 over root 3. Now, I'm going to type that in my calculator. 1 over root 3. I get 0.577. Oh, actually, I have the numbers here. That's nice. So they have the scale here. So root 3 over 3 is the same thing. So positive pi over 6, I have right here. And negative pi over 6, I'm right here. Okay, so it looks like a straight line so far. Let's see how that turns out. This is going to be pi over 3, 1. Okay, so pi over 3, 1. Right there. That should look pretty straight, but not quite. Pretty good. My last one here, pi, oh, sorry, this is pi over 4. My bad. I don't have pi over 4 in this graph, so I'm going to have to get rid of that. I skipped ahead a little bit. Sorry about that. Using the eraser here is a bit tricky on my pen. Okay, so this is actually pi over 4. I want to erase this. It's not let me erase it. Okay, came back. Seems like it's working now. So it's pi over 4, 1. This is pi over 3, root 3. Okay, so pi over 3, root 3. That's going to be way up here, actually. Pi over 4 is halfway between these two. Okay, and this one's going to be the same thing on the other side, though. They're not quite straight, so if I were to draw, this is what it looks like. Kind of curved and curved. Okay, so that's what it starts off as, but then I want to look at these last 2 points. They put down root 2 and then negative root 2. Now, what happens at negative root 2? So if I put this, finish off my graph here at root 2, the point is 0, 1. That's the point at root 2. Or same thing, if I put down negative root 2, this point is going to be 0 and negative 1 instead. Then I'm going to do the tan of this. I'm going to go y over x. Oh, y over x. Oh. So what happens? Well, I divide by 0, so I get this undefined problem here. So I divide by 0, I get an undefined problem. Now it doesn't just all of a sudden just become undefined, it gets closer and closer to being undefined, right? As I get closer and closer, as I start going upwards, my x value starts decreasing in size, decreasing in size, decreasing in size until I get to 0. But as it gets smaller and smaller and smaller, I get closer and closer and closer to infinity. I'm getting really close. I'm getting a huge number. So this is becoming an asymptote right here. So there's a vertical asymptote right here that my graph is approaching but not actually touching. The same thing on this side over here. So a vertical asymptote on that side. Now, what happens when I go to the other quadrants? Well, in quadrant 1, so remember this is quadrant 1 here. That's where all the positive pieces here. So this quadrant over here, this is quadrant 1, right? So this is also quadrant 1 because of the positive angles. This angle down, this is quadrant 4. This is quadrant 4 down here. So we just plotted quadrants 1 and 4. Quadrants 2, what happens in quadrants 2 is it starts over again. Here we have positive y values and negative x values. So these two quadrants here match up because of the cast. Remember the cast rule? The add sugar to coffee rule. Tan is negative in those two quadrants, in the C and the S quadrant, and the A and the T quadrant. These two quadrants, they're positive. So every half a circle, it starts over. So here, when it hits quadrant 2, it actually comes back down here, and then it goes back up. It's here, and then it goes back up that direction. So this is quadrant 2. Oops. Quadrant 2, and this over here is quadrant 3. Right? And then the asymptote, and then over here is quadrant 4 again. Right? And then when it's at this, and then it goes back to quadrant 1 again. So positive, negative, positive, negative. So it creates this picture right down here. Right? And you can see we have an asymptote every time the graph, this is the coast graph. Now the coast graph, remember the coast graph represents the x values. That's what's on the bottom of this, the x values. So whenever the x values end up being 0, we get an asymptote there. Okay. Explain what happens graphically. A vertical. Asymptote. Okay. Now, what you notice about this is that the period is not 360. Like the period of the coast graph is 360 before it starts going over again. But the difference between here and here is not 360. And here to here, because these are all the same. They start repeating over and over. That's only 180 degrees or pi, right? So the period is a little bit smaller. You can see down here the period of this pi. It mentions it down here too. So if you want to highlight something, you can. Let's highlight that. That's pretty important to know that the period is pi, not 2 pi. Okay, so let's think about the properties and the characteristics of this graph here. So the asymptotes, and there's an infinite number, it just keeps on going and going. All the asymptotes, starting, let's say, start at pi over 2, is pi that way, another pi this way, or pi back, or another pi back, right? And keep on going pies. So I create a general term for my asymptotes. My general term for my asymptotes are when theta is equal to pi over 2 plus pi n, n-e-i. Okay, so plus or minus a bunch of pi's back and forth, starting from the, we always want to start from the first positive angle, so the principal angle, and then we'll worry about the other ones later. My domain, now my domain cannot be these numbers. So my domain, which is going to be theta or x or whatever you want to call it. I think they labeled x here, so you probably put down x instead. I'm just going to use theta because I think those for angles. Is going to be everything but these numbers. Okay, you put in there like theta EI if you want to, or theta ER. It's all the other numbers but the ones that's represented by this restriction here. My range is different from the previous ones. My range actually is YER. There's no minimum, there's no maximum. It goes on forever upwards, down forever. Period. The period, which we already discussed, is pi. And x-intercepts, where do they start? Notice that they start at 0 and then every 180. So my x-intercepts are going to be, because they use x here as well, starts at 0, add pi any number of times, front or back. So I can simplify this down and get rid of the 0 and just go pi n, n-e-i. Now my y-intercept, you can see here my y-intercept is 0. So y is 0, 0. There you go. That's all you really need to know about a tan graph. I'm not going to ask too many questions about it other than what's the period, and any question that you could have, you just have to use the graphing calculator to do that. Okay. The next lesson here, we're going to do some more complex graphs. We're going to graph them in a graphing calculator and use our graphing calculators to solve them, or Desmos, up to you. I'll see you in the next lesson. Bye.